Hello everybody, this is Dr. Fouladian. We're going to start chapter 21 of the Martini, that is regarding the heart. That's the second part of the cardiovascular system. So far we talked about the blood, and now we're going to talk about the heart as the pump of the cardiovascular system. So just as an introduction, the heart is the pump that keeps the blood in motion. We talked about the whole function of the cardiovascular system, that is like a transportation system of the body that transport the oxygen and nutrient to all the tissue and cells of the body and bring back the waste and the carbon dioxide to the places so that they can be dumped out of the body and get to the exit points of the body, right? So we talked about the blood before, what do we have and how it does the function of the transporting of the material by connecting to them and all those other things. And now we're talking about the heart that is making the blood to just move, to be in the motion. Now, if blood stops moving, nutrient and oxygen supplies are exhausted, because if they just stay in the origin place at the factory that they have been produced, that's useless. They cannot get into the places that they are needed. They cannot get to the customers, right? So the heart beats about 100,000 times every day. And this is about 70 beats per minute. That's the regular, usual heartbeat in a regular person, right? The heart pumps about 1.5 million gallons of blood per year, and this is about 2.9 gallons per minute. That is about 5 liters, right? So the heart pumps between 3 and 30 liters of the blood per minute. So if you are not doing much of the activity, is about 5 liters. If you are doing lots of exercise, severe activity and all those ones, it may get up to 30 liters per minute too, right? So according to the condition of the body and the needs of the part of the body. So there is just some statistics to show us and remind us the importance of the heart, and every minute that if heart stops, what will happen? The oxygen and nutrient cannot get to the cells, and that's the one that we call it heart attack, when the heart stops. And following that, after a few minutes, a very short period, many of the vital cells, like for example the cells of the brain, even the cells of the heart itself, may die. So the heart is about the size of a clenched fist in each person. So the heart of each person is the size of a clenched fist of that person, right? My heart might be this size, your heart might be smaller according to your body figure, or bigger according to your body figure again. The heart consists of 4 chambers. We have 2 chambers on the top that we call each atrium. Atrium is singular for each chamber. Atria is plural for the both one. We have one right atrium, one left atrium. Both of them are called atria. Right. On the below part, we have 2 ventricles. Each one is 1 ventricle. 2 of them ventricles, simply like any other words, right, in English. So we have right ventricle and left ventricle. So therefore, simply we have 4 chambers: right atrium, left atrium, right ventricle, left ventricle. Now the heart pumps blood into 2 circuits. So we have 2 circulation of the blood. One is called pulmonary circulation. The other one is called systemic circulation. The pulmonary circulation is the one that circulates blood from heart to the lung and get it back from the lung to the heart. Right? What about systemic circulation? Systemic circulation sends the blood from the heart to all other parts of the body, to all over the body, all the tissues of the body that they need to oxygen and nutrient to get them, right? So all over the body receives the blood from the heart, and then after exchanging of the material, the carbon dioxide and waste gets back to the heart. That one is called systemic circulation. And the purpose of having systemic circulation is provide the oxygen and nutrient to all the cells and tissues of the body and bring back the waste and carbon dioxide to the heart, so that after that, in the next round, they can get to the parts that they are related, right? Like, for example, if the carbon dioxide gets back to the heart, in the next round, will go to the lung, and through the lung, it gets out of the body. If there are some other waste, they may go to the kidney, and the kidney can get rid of them. They may go to the digestive system gets rid of them. May go to the sweat gland, and the sweat gland gets rid of them. That was the whole purpose of having the cardiovascular system, to transport the material between different parts of the body, right? So what about the pulmonary circulation? Pulmonary circulation purpose is exchange of the oxygen and carbon dioxide. In other words, exchange of gases only. So the lung gets the oxygen into itself, right, from the air. Now, the blood from the heart gets to the lung, and the run back to the heart gets the oxygenated blood with itself to the heart, and then it circulates throughout the body. Then the next round, the blood that gets to the have gone to the lung, then it gets to the blood that has got into the heart, then it gets into the lung and gets all the carbon dioxide to the lung, and the lung gets rid of that. So in simple words, pulmonary circulation is not for the circulation and the needs of the lung, is for the gas exchange of the whole body, right? And the systemic circulation is for the exchange of the nutrient and oxygen and carbon dioxide for the whole body. Now let's go and see that. So here in this picture, you see a simplified schematic presentation of the circulatory system between the heart, that's located in the thoracic cavity, and all those blood vessels. So again, emphasizing that whichever blood vessel that brings the blood out of the heart is called an artery. And whichever blood vessel that brings the blood back toward the heart, it's called a vein. And these are regardless of the fact that if the blood that they are getting out of the heart or bringing back toward the heart is full of oxygen or it has less oxygen, right? So no matter what type of the blood that they have, full oxygenated or less oxygenated, sometimes they call it deoxygenated. That's not a very good term, but anyhow, you may see or hear that. But regardless of the situation and the condition of the blood, the direction of the blood determines which blood vessel is artery, which blood vessel is vein. If the blood vessel takes the blood out of the heart, it's an artery. If the blood vessel takes the blood back toward the heart, it is called a vein. So that's a general definition. There is no exception for that. So having said that, now, as you see here, you have here the chambers of the heart. This is the right, as you see, this is the right side of the heart, right? And this is the left side of the heart. So here on the top you have atrium, one atrium here, this is right atrium. You have the other atrium here, this is left atrium, you see one part of that. Then on the bottom you have ventricles. You have right ventricle here and you have left ventricle here. So far so good. These are 4 chambers of the heart. Now you see the blood vessels that are connecting to each one. For the right atrium, starting from here, we have 2 blood vessels that bringing the blood back toward the heart. So, or they should be artery or veins. They bringing the blood back toward the heart. They are veins because bringing blood back toward the heart, right? So we have one here comes from the top part of the body, 2 arms and head and neck, right? From this area to the top, right? We call this vessel as superior vena cava. Then we have another one that also comes to the same chamber, to the right atrium. This one brings the blood back from all over inferior part of the body, right? From the lower leg, from the abdomen, all the things that are located below the heart, right? This vessel is called inferior vena cava, right? So far so good. So we have 2 vessels, 2 veins that bring the blood back toward the heart, and they both go into the right atrium. This one is superior vena cava, inferior vena cava, both of them go to the right. So then you see here you have one vessel that comes actually out of this part, out of the left ventricle. It goes beyond in the back here, haven't been shown very well in the beginning because it's behind the other vessels. And it goes up, makes a loop, and goes down back here. And it sends the blood to actually all over the body. As you see, this vessel is called aorta. This part that goes up is called ascending aorta. Then makes a loop, we call it arch of the aorta, and then descends, we call it descending aorta, right? That's the biggest artery of the body here. Now, as you see, when it gets here, it said some branches haven't been shown all, it just simplified. Some branches that goes and supplies all these upper part, the 2 arms and head and neck, right? All these ones. So this is the supply of the nutrient and oxygen to these parts, upper part of the body. And as it continues, it sends some branches to the thoracic cavity, and then it goes into the abdomen, sends branches to the abdominal area, goes to the lower extremity, sends branches into the lower extremity, and just as you see, the blood that comes out of the left ventricle here gets into the aorta and then supplies all the nutrient and oxygen to the upper part and lower part, to all over the body, right? So now if we put these all together, so just mentioning that as this vessel getting the blood out of the heart, this is an artery. So aorta is a big artery, the biggest artery of the heart. Now putting these 2 together, we are talking about the systemic circulation. So let's start from the beginning here. You have some blood in the left ventricle, then both ventricles squeeze, they have the contraction, right? The muscle, the cardiac muscle of the heart contracts, and what happens? Pushes the blood into the aorta, right? This is an artery, takes the blood out of the heart. It sends to the upper part and it sends to the lower part. Each part have been shown in very detail, but it just showed as a schematic part. Imagine you have these vessels. As they get further, they get smaller. At the end, they become capillaries, right? Those capillaries at every single place of all our body, at every single inch of the body, or even a smaller size, right? You have all those tiny vessels that we call them capillary. So near every cell of the body, there will be at least one capillary, right? So when the blood that has oxygen and nutrient inside that gets near the cells of the body, what will happen? At the level of the capillary, we have the exchange of the material, right? The nutrient and oxygen gets out of the blood, get into the interstitial tissue, as we discussed before, due to what mechanism? Right, due to diffusion, because those materials go from the higher concentration to the lower concentration. We have a blood full of nutrient and oxygen, so the concentration is higher than the interstitial tissue, so they move to the interstitial tissue. Then from the interstitial tissue, now they have higher concentration than the concentration of them inside of a cell. So they move toward the inside of the cell. So that's the way that the nutrient and oxygen that have come through the aorta, they get into the cells of the body, all over the body. Upper part, lower part, everywhere, right? Then, after they exchange the material, now as the blood it moves, the concentration of the nutrient and oxygen gets lower and lower, right? Because now they are moving out, right? So as they're moving, they go toward the venous side, right? As the concentration of the oxygen gets lower, the concentration of the nutrient gets lower. Now, at one point, we have around the blood vessels, we have some veins that their concentrations are more than the veins that we have inside of the blood. So what will happen? Those veins now from the cells get into the interstitial tissue, and from the interstitial tissue get into the blood, right? And as the blood is moving back toward the heart, they get all those waste with itself toward the heart, and where they go, they all from all over the lower part get through the inferior vena cava, get to the right atrium, and from the upper part of the body includes, like it's shown here, but includes every structure here, upper extremities, everywhere. They go back to the superior vena cava and they get to the right atrium here. So this is the part that we call it systemic circulation. It has systemic arteries that start with the aorta and they branch, haven't been shown all branches, but you see the whole picture here, right? And they exchange the material at the level of the cells and tissues, and they bring back the waste and the carbon dioxide here to the inferior vena cava and superior vena cava, that they are systemic veins. Now they branches from the beginning here and they get into the right atrium. So this circulation that starts from the left ventricle, then go into the aorta and all the branches and get back toward the inferior vena cava, superior vena cava, and finally gets to the right atrium, is called the systemic circulation. So you need to know the beginning, the end, and whatever you have in between. Good? That's the systemic circulation. The purpose is the exchange of the material between all the cells of the body and the heart. Right. What about the pulmonary circulation? Pulmonary in general means related to the heart, right? So pulmonary circulations Again, it has pulmonary arteries and pulmonary veins. And by definition, again, pulmonary arteries are the arteries that bring the blood out of the heart, and pulmonary veins are the vessels that bring the blood back toward the heart. Pay attention to the definition. As we said, there is no exception to this definition, and we're not mixing that with the fact that they may have a full oxygenated blood or less oxygenated. Now let's go and see. So here you see that after the right atrium that received all the blood back from the body to the superior vena cava and inferior vena cava and get to the right atrium, now those bloods are passing here through a valve. So mentioning here that between the atrium here and the ventricle, between each atrium and ventricle on the same side, you have a valve, right? You have one valve here. We call those valves atrioventricular valve. Excuse me. So you have one in the right side, one on the left side. So you have right atrioventricular valve here, left atrioventricular valve on the left side. They have other names too, right? The one on the right side also, besides named right atrioventricular valve, or sometimes in abbreviation we just say AV valve for atrioventricular, right atrioventricular valve, right AV valve. It has another name too. We call it tricuspid. Just give me a minute, please. Sorry about the interruption. I had to get some water. So we were talking about the right atrioventricular valve, that it has another name. We call it tricuspid. So the blood that gets from all over the body to the right atrium now passes through the tricuspid valve and gets to the right ventricle. Now, when the heart contracts and pushes the blood out of the ventricles, let's see where this blood can go. As you see, the only place that has remained is this vessel that can get blood out of the right ventricle goes here. We call this vessel as pulmonary trunk. This pulmonary trunk, we're going to talk about this all in more detail, that gets the blood out of the right ventricle toward the lungs. So these are just, again, schematic presentation. This pulmonary trunk is a very big vessel, therefore we call it trunk. Whenever we have a big vessel that later gets more branches, then we call it a trunk, right? So we have this pulmonary trunk, and as we said, pulmonary means related to lung, right? As it's going to go into the lung, we call it pulmonary. As it is very big, we call it pulmonary trunk, right? Then later, it gets two branches, one to the left side here, one to the right side here, right? We call each one of those pulmonary artery. And these are all artery. Why? Because they are taking the blood out of the heart, right? So they take the blood out of the right ventricle, left pulmonary artery, right pulmonary artery, each one goes to one lung. And when they get into the lung, they branch and get smaller until they get capillaries, very tiny capillaries. So those are all pulmonary vessels, and at the end they are pulmonary capillaries. And can you guess what's the job of the pulmonary capillaries? Like any other capillary, exchange of the material. What are those material for the lung, for the pulmonary capillaries? Those are the gases. So they're going to exchange the gas. they're going to exchange the oxygens and carbon dioxide, right, with the lung. And when they finish the job, we're going to talk about that, the direction of the movement and all those ones. But again, what's the mechanism? Diffusion. Whenever we have higher concentration of the oxygen, moves toward the lower concentration. Like in the lung, we have the higher concentration of the oxygen, it moves toward the capillaries, right? And then we have the lower concentration of the carbon dioxide in the lung, it gets the carbon dioxide from the capillary, right? So then at the end, they become the venous size, then they join together, make the bigger vessels, and what will happen at the end? So these are all the capillary parts here have been shown big so that you can see that these the parts that are doing the main jobs here. Capillaries, right? In the whole cardiovascular system, these capillary are doing the main job. So at the end, when they all connect and become bigger and bigger, make the big veins. And the veins are getting back toward the heart. Where these pulmonary vein, we call these ones pulmonary vein because they're coming back from the lung, right? These pulmonary veins get back to the heart. To which chamber of the heart? To this one. What did we call this? Left, as you see, is on the left side. Is this on the top or bottom? Is on the top. Therefore, it is left atrium. Pay attention. From the both lung, from the left lung and from the right lung, you have veins that coming back, pulmonary veins that all coming back to the left atrium. Actually, we have two pulmonary veins from the left side, two pulmonary veins from the right side, right lung I mean, that all get back to the left atrium. So we have four pulmonary veins that all getting back to the left atrium. So from the right side is behind the heart, you don't see in this picture here. So this circulation of the blood that starts from the right ventricle goes to the pulmonary trunk, pulmonary arteries, at the end pulmonary capillaries, and finally gets back to the pulmonary veins and get into the left atrium. This is all pulmonary circulation or circuit. And the job of that is exchanging of the oxygen and carbon dioxide. So that was the whole picture of the two circuits of the circulation that we have in the body, systemic circulation and pulmonary circulation. Now we are going to review all these ones in more detail. So first things that each circuit involves arteries, veins, and capillaries. So again, we emphasizing that arteries transporting blood away from the heart. Veins are the blood vessels that transport blood toward the heart, and capillaries are the tiniest blood vessels that interconnect arteries and veins, right? So here, this is other way to show all those relations between this is a lung, as you see here, and here from the lung, you have the pulmonary trunk that bring the blood toward the lung, and pulmonary veins that bring the blood out of the lung toward the heart, right? Then, so getting back from here, you have right ventricle of the heart that, or start from here, from the right atrium of the heart, the blood goes to the right ventricle. From the right ventricle goes to the pulmonary trunk. From the pulmonary trunk and two pulmonary arteries goes to the lung. From the lung goes to the pulmonary veins, and from the pulmonary veins gets back to the atrium. Then from the left atrium, from pulmonary veins goes to the left atrium. So that's the whole pulmonary circulation. What happens to the left atrium? It gets to the left ventricle, and from the left ventricle, as we discussed, gets into the systemic circulation, goes to the aorta, and then from the aorta goes all over the body, and when it gets to the capillaries, exchange of the material, and then gets back through the superior and inferior vena cava, gets back to the right atrium. Pay attention, you have a coronary sinus as mentioned here. Later we're going to talk about that. That's regard the circulation of the heart itself. That's the vein that we have bring the blood back from the exchange of the material from the heart itself. That one also gets back to the right atrium too. So that was the summary of all we have discussed. And you see that you have tricuspid valve between the right atrium and right ventricle. You have bicuspid valve between the left atrium and left ventricle here, right? And this is a good picture that also, besides showing the arteries and veins, oops, I have to stop it. Sorry about that. So we're talking that just besides that shows all the chambers, the 4 chambers of the heart. It shows the pulmonary circulation and also the systemic circulation all here. Also, this color of the blue and the color of the red here is intended to show that if the blood has lots of oxygen, therefore has been shown in the color of red, right? As a full oxygenated blood, that it looks bright red, right? And if it has less oxygen, that blood may looks like more blue, that has been shown in this one, right? So later we're going to review these ones and go over that, why the reason of this one. So if we go right here, you see that the blood that is coming back, when the blood goes through the aorta, goes to the body after exchange of the material all over the body, those oxygen that was in the blood now has gone to the tissues. So in the blood, there is not much oxygen has left, right? So the blood that gets back toward the heart through the superior vena cava, inferior vena cava, and all those ones get to the right atrium, there is not much of oxygen in there. The same blood gets to the right ventricle. From the right ventricle, the same blood goes to the pulmonary trunk, and through the pulmonary arteries, the same blood gets to the lung. Up to this point, all these bloods has not much of the oxygen. I mean, it has less oxygen compared to the beginning that it came out of the heart, right? So this less oxygenated blood gets to the lung. What will happen in the lung? The fresh air has come from the outside, has gone into all the part of the lung that we call it air sac or alveolus. Then the blood that gets nearby, all those alveoli, they get the oxygens from the lung, because inside of the lung we have more concentration of the oxygen. Those oxygens gets into the capillaries, to the pulmonary capillaries. And as the pulmonary capillaries gets back all the way to the pulmonary veins, now those capillaries and veins have more oxygen, therefore they become more red, right? So those ones from the pulmonary vein gets to the left atrium. From the left atrium, they get to the left ventricle. So all these ones are full of oxygen. And what happens from the left ventricle? From the left ventricle, when you have a contraction, boom, that full oxygenated blood just go all over the body again. Now, a blood with lots of oxygen is available to all the tissues of the body. When through the aorta goes to all the tissues of the body, and again is ready to exchange the oxygen and give it to all the tissues that they needed, right? So let's go here and see the talk about the heart. Let me stop here and then we will continue the recording and we